Hello, today I will teach you how to do some basic bending moments and shear force diagrams. Okay. Before you start it, we need to understand so-called the basic beams. Okay. The left-hand side we call the overhand. The left-hand side is without support on the left, and we say this portion is cantilever. Okay. And the right-hand side is simply supported. There's two supported to support the beams, and the bottom one is so-called the cantilever. Only the left hand side with a support. Okay, and you need to understand this is so-called the cantilever beam. Okay, and I just show you this is a so-called loading diagram on the top, and then you will see this is a bending moment, and then this is shear force diagram, and then bending moment. Actually, when you understand this bending moment and shear force, you can design the basic reinforced concrete beams or steel beam. Okay, and then before we start it, you also need to understand so-called the moment. Moment is equal to force multiple distance. Okay, this is a basic formula of moment. Okay, and we try to start the so-called basic point no force support first. Okay, and then this on the top, this is only have a 1 point no. Okay, and then the middle one is just cut the left hand side to be 2 pieces, and then you can see only we have reaction force, and then there's the middle side is a shear, and then the moment. And then the right hand side is also the same, because you can understand upward force is equal to the downward force, clockwise equal to anti-clockwise equal to clockwise, and then the right hand side should be the same. Okay, and then from the equilibrium equation, you will understand Fi equal to 0, and then you will see this Ra is equal to V. Okay, this means upward force equal to downward force. Okay, and the moment along AA is equal to force Ra multiples D is a force times distance, is a formula. Okay, and then you will see actually M is equal to Ra multiple X. Okay, we see this another example. We have a middle point no. Okay, and then try to see how to do the so-called bending moment and the shear force diagram. Okay, and then the first one, you need to understand we have a 2 reaction force. Normally, if you apply the force in the middle, the loading will be shared into 2, and then you will see the reaction force should be P divided by 2 left hand side, and then right hand side should be the same, P divided by 2. After that, based on the equilibrium formula, okay, you can imagine cut into 2 pieces. The left hand side reaction force equal to V, and then you will see V equal to P divided by 2, and then do the same things for the moments. Moment is equal to force. This is a P divided by 2 is a force, and then divided, and then multiple X is a distance. Okay, you will see the moment is equal to Px over 2, and then we try to put X is equal to 0. Try to think this is start from the left first, and then you will just put into the formula V equal to P divided by 2, M equal to, because we put X is 0, and then P is also 0. Okay, and then we find the moment in the middle. Okay, and you will see just put L over 2 in here, and then you will find out the moment is PL divided by 4 is the middle moment. Okay, and then the shear is the same, P divided by 2. Okay, and then you will see when the X is equal to L is the shear is the negative, and then you will find out the bending moment in here is something like this. Okay, when we have the shear in the middle, it should be negative. Okay, and then you will find out the bending moment. Okay, and this is for example, if this is a 20, actually this is 10, and then we go 10 because we have 20 go downward, and then you will go downward to the -10, okay? And PL over 4 is a formula. P is 20, L is 6, and then you will divide it. The result is 30, okay? And then this is so-called another example of the bending moment of the uniform load. Assume this is 5 kilonewton, and then you will find out the first step is assume this is a reaction force A and reaction force B, okay? And then try to think about this is W is uniform load, the parameter, okay? And then the length is L, okay? Do something the same of before. Do the simple first, okay? And then you understand WL is the total force, and then there's a 2 support, and this mean the force and reaction force is WL divided by 2, okay? And then you will see the formula like this, okay? And then because you also have a downward force along X, you need to minus WX, okay? And then the moment is more or less the same. Force is a WL divided by 2, multiple distance is a moment, and then also there's a moment downwards, the WX divided by, because they add in the middle, and then we will have X over L, X divided by 2, and then you will find out the moment. There's a equation, okay? Just do the same for the X equal to 0, L over in the middle point, and then the end point. When X is equal to 0, you just put the formula in here. This is a 0, and then you will find out the WL over 2 is a shear, and then if we put X in the moment equation, you will see 0 and 0, and then you will find out 0. And we will put the X in the middle, is mean the WL divided by A, and this is the equation, and you will find out the diagram something like this, okay? And just put WL divided by X here, you will find out the bending moment diagram. Okay, that's it. Thank you. Bye bye.